You know, our whole world, it basically runs on data. Everything from your social media feed to your bank account, it's all data. But how does all that information stay organized and not just spiral into total chaos? Well, the answer is a really powerful language called SQL, and we're about to go from zero to writing our first query right now.
I mean, really think about it. We've all been there, right? Staring at some horribly messy spreadsheet. You've got duplicate rows. You have no idea which version is the right one. It's a nightmare. Now just imagine that same mess, but on the scale of a global company. It would be absolute chaos.
And that, right there, is the exact problem that databases are built to solve. On one side, you've got that spreadsheet mess. But on the other, you have the beautiful order of a database. It gives you what's called a single source of truth. So everybody's working from the same correct information. It sets up clear relationships between data, and most importantly, it enforces rules to keep everything clean and trustworthy.
Okay, so how do we actually talk to these amazing, super organized databases? Well, we use a universal language. It's called SQL, which stands for Structured Query Language. And honestly, the best way to get it is to just use it. So let's build a tiny little database from the ground up and see exactly how this all works.
Now, a good way to think about SQL isn't as just one thing, but more like a language that has four main dialects for different jobs. You've got DDL, which is for defining the structure, the blueprint. Then there's DML, for playing with the data inside. And finally, TCL and DCL are kind of like the security guards, managing the whole operation and controlling who gets in. We're going to meet all of them.
All right, first things first, before you can put any data anywhere, you have to build a container for it, right? This is our blueprint phase. And to do that, we're going to use that first dialect we mentioned, DDL, the data definition language.
Okay, I know this might look a little technical, but trust me, it's actually pretty straightforward. Think of it like you're designing an empty form. We're just saying, create a table, let's call it students. And this table needs a few columns, one for a student ID, one for their name, and one for their age. Now that primary key part, that is absolutely crucial. It's a special rule that forces every single student to have their own unique ID number. It's like the database's secret weapon against those messy duplicate entries. And boom, just like that, our single line of code has created this, an empty, perfectly structured container for our data. See how it has the exact columns we defined? We can't accidentally add a favorite color in here because our blueprint, our structure, won't let us. That's the power of setting things up right from the start. Okay, so our container is built. It's time to bring this thing to life. We're going to start adding data, and then, the fun part, asking it questions. And for this part of the job, we switch to our second dialect, DML, the data manipulation language. So if creating the table was like designing the form, this insert command is basically us filling out a couple of them. It's super simple. We're just telling the database to put a new row into our students table with the values for our first student, Asha, and then our second student, John. Easy enough. And there we go. Our table is now populated. We've got our first two records. But here's the thing. Just storing data is kind of pointless if you can't get it back out, right? The real power of SQL is being able to ask for exactly what you need and get it instantly. Now this is the heart of SQL for so many people. We're going to ask our database a question. Let's break it down. We're telling it to select the name column from our students table. But, and here's the key, only give us the ones where the age is greater than 15. And just like that, the database does all the heavy lifting. It instantly filters out Asha and gives us the exact answer we were looking for. John. Now, can you imagine trying to find that one person in a spreadsheet with like 10,000 rows? With SQL, it's instant. Getting one piece of data is cool and all, but the true magic of SQL, the real wow moment, happens when we start connecting different tables together and summarizing information. This is where we unlock the deep insights. This is where it gets really, really powerful. So here's our students table again. We know who they are, but what courses are they taking? This table can't tell us that. It's only got part of the story. And that's why we have this second table, called enrollments. This is just smart database design. Instead of cramming everything into one massive table, this one just acts like a bridge. It connects students to courses using their unique IDs. You see how student ID 1 is linked up with course ID 1. That's our connection right there. So using a really cool command called a join, we can tell the database to look at both tables, match up those IDs, and give us this beautiful combined result. And there you have it. Now we have the complete picture. Asha is in math
and John is in science. We've connected the dots.
But why stop there? We can go even further. Instead of just listing things, we can ask the database to summarize stuff for us. Think of the count command as just a simple tally counter, and that group by command, it tells the database to first sort everything into separate piles. You know, a pile for math, a pile for science, and then start counting.
And check this out. This is the result. Instead of a long list, we get this awesome clean summary. We can immediately see there's one student in math and one in science. Just imagine doing this for a huge university. SQL can figure it out in a fraction of a second. It's incredible.
Okay, quick sidebar. Here's something that trips up a lot of people when they're starting out. The difference between where and having. They both filter stuff, but they do it at different times. Where filters the individual rows before any of the counting or summarizing happens. Think where age greater than 15. Having, on the other hand, filters the final groups after all the counting is done, like show me courses having more than 100 students, before versus after.
So, we've built our database, we've put data in it, we've asked it some pretty complex questions, but in the real world, we also have to protect that data. It's got to be safe and reliable. And that's where our last two dialects come in. Think of them as the official guardians, transaction control language and data control language. Okay, picture this. A simple bank transfer. It's really two separate steps, right? Step 1, take $100 out of account A. Step 2, put that $100 into account B. But what if the power goes out right after step 1 finishes, but before step 2 can even start? Uh-oh, account A is down $100, and that money never showed up in account B. It just vanished. That's a total disaster.
The solution to this scary problem is something called a transaction. It basically wraps both of those steps into a single all-or-nothing package. If both steps work perfectly, you commit the changes, which is like hitting the final save button. But if anything goes wrong along the way, you roll back, and the database instantly goes back to exactly how it was before you started. It's the ultimate undo button. So after that whole journey, it really all boils down to these three big ideas. First, you use DDL to create the blueprint. That's the structure. Second, you use DML to bring it all to life, adding your data and asking it questions. And finally, you have TCL and DCL, which act as the guardians, making sure all of your data stays safe, secure, and reliable.
And that's really the heart of it all. SQL isn't just some boring tool for storing information. It's a language. It's a way to have a conversation with your data, to uncover hidden stories, and to find real answers. So that just leaves one final thought for you. Now that you know the language, what questions are you going to ask?